Okay, you guys, so I'm going to be teaching you about many ways you can factor a problem. And the way that you determine which factoring technique you use is based on what your original polynomial looks like. So, the next technique I'm going to teach you is called a difference of two squares. Okay, which pretty much it gives it away in the name what you're looking for. So, first of all, you have to have a difference, which in math, the word difference means to subtract. So you have to have numbers that are subtracting. Difference of two, so you have to be subtracting two terms. Okay, so when you're using a difference of squares, you have to start off with two terms. They have to be subtracting, and they have to be squares or perfect squares. They have to be two numbers, or they have to be a number that you can multiply two numbers together to get that number. So essentially, you should be able to square root each of these numbers because they're perfect squares. Okay, so you must have two terms, you must have a difference, and you must have two perfect squares that eventually we're going to be square rooting. Okay, so this is what the formula looks like. This is what your polynomial is going to look like when you get your problem. Okay, so you're going to have two squares that are subtracting, difference of two squares. This is what your final answer is going to look like this. So after we square root the first and last term, which the square root of a squared is a, because a times a is a squared, and the square root of c squared is c, because c times c is c squared. We're going to ignore the negative. So after we square root the first and last term, all we're going to do is take those values and subtract them and add them, and then you're going to be done. Okay, which you're probably like, Miss Long, I don't know what you're talking about. Well, that's okay. It will make more sense when I solve a problem. So why don't we get going on a problem? That sounds like a blast. I love solving math problems, which you guys told me you love to as well. So I'm so excited to work out these problems with you. Okay, so we're going to be doing a total of 4 problems, but for right now, we're just going to do example 10. So, oh no. What did I do? Sorry guys, the demon cat's got me. Ah! Stop it. Okay, we're back. Sorry, guys. Good golly, Miss Long. But anyways, we're gonna do 4 problems. And again, your problem that you're gonna be getting will look like this. You're gonna have 2 terms. They're both gonna be perfect squares, which means you can square root them. And then they're gonna be subtracting. Difference of 2 squares, or difference of 2 perfect squares. Again, mathematicians are lazy, so they left off the word perfect square. Okay, but that's really what it should be called. If I were to name this technique, it would be a difference of 2 perfect squares. And probably like perfect squares, like a cat purring. Board slapper. Anyways, before we have too much fun, why don't we get started on these awesome math problems? Okay, so this is what your problem is going to look like. You're going to have 2 perfect squares that are subtracting, and then your answer, after we square root each term, we're just going to simply subtract and add our final values, and that will be our final answer. So let's get going on example 10. I'm already excited. Let's go. Okay, so example 10. Again, this is like your A term. Your first term is the A, okay, and the second term is the C. Okay, now when you do a difference of squares, we will be square rooting each of these terms because they are perfect squares. You can square root them. Now, be careful, you guys. This is just a technique for factoring. In the real world, you can't just take an expression and square root any number that you feel like it. Okay, like if I saw this, I can't just square root the 81 and I can't just square root the x squared. Okay, that is illegal actually. Now, in the problem, I'm going to be square rooting them because it's a factoring technique. But if you're trying to simplify this down, it is illegal to square root each of these numbers. Okay, which if you have more questions on that, feel free to ask me about it. But just be really careful. This is just a technique for factoring. It's not a technique for solving, so just be careful. Okay, so to get my A term in my formula, I'm trying to get an A and a C so I can write my final answer by subtracting and adding my A and C. So the way that you get your A and your C, to get A, we are going to square root the first term, which is the x squared. And then to get the C, we are going to be square rooting the second term. But we are going to ignore the negative. So don't use the negative. So I'm going to square root the 81 without the negative. Okay, so we're going to square root our first term and our last term. That's all we're doing. Okay, so the square root of x squared, well, what times what gives you x squared? It would be x to the first, because x to the first times x to the first. Remember, when you multiply variables with exponents, you add them. So 1 plus 1 is 2. So you could write this as x to the first or just as x. And then the square root of 81, what times what will give you 81? That's the same exact number. You guys always know the right answer. It is 9. Nice job. Okay, so this is like my A term. So this is my A and this is my C. And in our final answer, all we do with the A and the C is one time we subtract them and one time we add them. Then we are done. Okay, so one time I'm going to do x plus 9. Sorry, it really doesn't matter the order. One time we're going to do x minus 9. X minus 9. And one time we're going to add them. So one time I'm going to do x plus 9. And that's all you guys do. This would be my final answer. So there's really not much to doing a difference of squares. All you do is you square root the first and last term. And then one time you subtract them and one time you add them. And then you're done. Which remember, you guys, if you were to distribute this back out, you would get your original answer. Like x times x gives me x squared. X times positive 9 is 9x. X times negative 9 is negative 9x, which negative 9x plus 9x will cancel and turn to 0. And then negative 9 times positive 9 is negative 81. So you end up with the same answer. So that's always a good way to check yourself. If you want to redistribute back out your answer, you should always end up with what the problem was. All right, well, with that being said, why don't we tackle example 11?